Last week, we looked at about three pre-construction considerations of the Hanyang-Sujian River Point apartment: the cemetery, the topography, and the access road. Today, following last week's content, we will look about the other additional pre-construction considerations. What is the most noticeable point when you look at the site image? As you see, the construction work are carried out adjacent to the survey station. In particular, 101dong, 102dong, and 103dong, which are scheduled to be constructed in areas near to the railway, are included in the railway protection zone. In other words, the tower crane required for the construction of Building 101 to Building 103 will be located in the railway protection zone. The railway protection zone is an area within 30 meters of the railway boundary line. The fact that the tower crane is located in the railway protection zone means that there is a possibility that the working radius of the tower crane will cause a safety accident. Therefore, it was approved for approval of railway protection zone activities, and finally 6 tower cranes were approved, adding Unit 2 to the 5 tower cranes that already existed. The key implementation conditions of the approval include the deployment of the Railway Operation Safety Manager, prohibition of intruding special high-pressure lines in the railway boundary of the tower crane, installation of railway soundproofing facilities, and handling civil complaints to maintain outdoor noise of 65 decibel, automatic safety diagnosis every 2 meters, and installation of railway facility measuring instruments. And as a final pre-construction consideration, let's look at the most geographic and geological features, which is the most important part. First, topography. As we mentioned last week, the biggest topographical feature of the construction site of the Hanyang-Sujian River Pine is the level difference. This is a visual representation of the level difference on our side. First, let's talk about the east to west direction. The side with Gyeomdaesan Mountain in the middle has the relatively high topography, and it changed to a lower level towards both sides. If you look north to south direction, you can see that the terrain gets higher as you go up to the north. The conclusion that we can draw from these two data is that the highest of the topography near the Gyeomdaesan Mountain of our site is the highest, and the further away from it, the lower it gets. By considering these geographical differences, safe and effective construction should be carried out. Let's move on to the geological aspect. What you need to learn about the geological aspect is ground research. Ground research means surveying to find out the formation of the stratum and soil layers, the condition of groundwater, the properties of each strata and soil layers, and to provide necessary data for the design and construction plan of structures. There are two main types of the ground research. There are indirect research methods such as existing data survey, and direct research methods such as the field survey, test excavation survey, and physical exploration, sounding, tree survey, and original location test. If the foundation is unstable, tilted building can be made, which is very dangerous. So, in order to create a stable foundation, ground research is an important factor in the construction process because it is necessary to check things before the construction. Then, what are the results of the ground survey on the construction site of the River Point apartment in Seoul? Let's look at the distribution of rocks shown by the ground survey. Weathering rocks mainly existed on the left side of the site, that is, where 102 to 104 buildings were to be built. The soft rock mainly existed in the center of the site, where 105 to 107 buildings were to be built. And two types of hard rock and soft rock existed on the right side of the site, where 108 to 112 buildings were to be built. Next, the amount of rock that needed to be dug out during construction. The largest proportion, with 55% of the total amount to be dug, was soil. The 41% was hard rock and the soft rock, and the weathered rock was taken up to the 4%. And this is the total table. In general, in order to make a building safe, you might think that the foundation, which is the basic of the building, must be deeply embedded so that the ground can endure the load of the building. As you can see from the table, our site has a lot of rocks. So, how can we solve this problem? What we need to look here is the bearing capacity of the soil. The bearing capacity of the soil is the stress on the bottom of the foundation when you support the upper load. Briefly, it's the force that the ground holds. For a stable foundation, the value of a bearing capacity must be high and the strength of the ground must be strong. To do so, we need to improve the fragile part of the ground and analyze geological factors to find out which part of the ground is fragile. The foundation plate must be placed on the ground to begin the construction, because if there is weakness in any part, the foundation plate will tilt or sink. The intensity is about 30 to 50 tons. Among the rocks found during the ground survey, the ground where several small-sized rocks are distributed is considered to be weak, so it will be dug out through blasting. On the contrary, the ground formed of huge rocks will be used by the base of the foundation plate. It's because it is not easy to dig out the huge rock, and because of its large bearing capacity, the value is high enough to proceed the construction process. As a result, the concern of the stability that the foundation is difficult to penetrate deeply due to the huge rock could be resolved by the concept of having a large bearing capacity because it is a rock. Let's go back to the previous data. These values in blue can be determined by the ground survey. Groundwater is water in which rainwater or part of snow penetrate into the ground and fill the gap between strata or rocks made of sand and gravel. As you can see, the level of groundwater varies depending on the ground where each building will be built, from 101 to 112. In particular, 112 buildings have the highest groundwater level, and it is essential to dig out groundwater to prevent weakening due to groundwater or cracking due to freezing in winter. Next week, we will review the actual construction process in earnest and finish this week. Thank you for watching.